Hey guys, in this video I'm going to introduce to you the integration of inverse trigonometric functions and show you some examples of them. So let's go over the rules for them first. So the integration of these are identities you're going to have to memorize because proving them will take far too much time, so you're better off just memorizing them and learning how to use them and apply them. So the integration of 1 over root, I'm going to put a thing here so you can see it. 1 over root a squared plus u squared du is equal to sine inverse of u over a plus c. A is just any constant. It's any one, like for example, 1, 2, 3, 4, 5, whatever, right? The integration of 1 over a squared plus u squared du is equal to 1 over a tan inverse u over a plus c. A is the same thing. Now, there's more, and I'm going to show you them right now. So the cos one, right? So if you see this over root a squared plus u squared, right? Well, actually, this should be minus. But root, yeah, 1 minus. Let's do it like this. 1 minus. Right? This would give you cos. Okay, this would give you, let's see. Okay, that's what that would give you. If you see this one, and it similarly has a negative, then it's just going to be cot inverse. Okay. If you see one that is secant, so this one would be secant. Actually, I didn't say what secant is. Secant, for example, is 1 over u absolute value u squared minus 1, right? Du, this would give you secant inverse of u plus c, right? If you get a negative of this, then it would be cosecant of negative 1 over u root u squared minus 1 du cosecant inverse. Okay, so now let's do some examples. So in this one, we have our a is equal to 1 and our u is equal to 4x, right? So what does this formula fit though? It fits the first one, no? So let's do that. But there's a little trick here because, see, u there has no constant. It has no, the constant in front of it is 1. Here it's 4, right? So if we want to do it, right, we're going to have to multiply this thing by 4 over 4, right? Because we can't just bring another constant into the derivative, which we're going to get right now. Let me do it and I'll show you what I mean. So, 4 over 4, well, you'd have to do substitution for that actually. So let me do an easier way. So you would get sine inverse 1 over 4 times 4x, right, plus c. Now what's the reason for that? Right, so let's rewrite that integral. Now it's just dx over root 1 minus 4x squared. Right, that's what it was. So now we need to convert it. We need to do u-substitution, no? So let's just say u is equal to 4x, du is equal to 4 dx. Dx is equal to du over 4. Now you see why? Because, okay, maybe you don't yet. It's okay, and that's okay. So let's plug it in. Change the variable, so it'll be du 1 over 4. I'll put that there. right? Root 1 minus u squared. Now we can use this formula, right? But you can skip that substitution just by doing it in your head, kind of thing, which will just give you to 1 over 4. And if you take the derivative of this, you'll go back and you'll get this answer. Okay, next one. U is going to be equal to 3x because, we just take the root of this term. So root of 9x squared is 3x. A is going to be 2 because root of the normal, root of 4, 2. What formula does it fit under? Same one again, right? It's again under this one. But again, the constant is okay, right? But our variable, it has a thing. So what do? We don't want to go through all that, right? You could, if it's your first time doing it, you should, right? But let me show you a shortcut, right? That's what you're here for anyways. I'm assuming. So let's say sine inverse our a is 4, or yeah, a is 4. Oh, a is 2 actually, sorry. A is 2, right? And then we got the u above it, so 3. Put the x here. Did I put the x there? Yeah, I did put the x there. Plus c, and I'll just divide it by 3. That's all you have to do. Okay? So you can generalize that formula even more and just say that it's, so instead of making it that, you can make the formula this. Du over a squared minus bu squared, or b squared u squared. Okay, and that would just give you 1 over b times sine inverse u over a. You could do it like that, right? But this one's redundant because you can just, if it's a very complicated one, this will not hold, and you'd have to do substitution either way. So now what is this one? Dx over absolute value root of x squared minus 1. This one seems like this. Secant inverse. So we'll just do it here. It's just variables are replaced for x with u. So secant inverse of x plus c. This one, -3 plus 1 over. So see this one, whenever I see this, I just instantly think tan. It's something to do with tan. It's a negative, so it's going to be cotangent. Is that right? Cotangent is just a negative. Yes, it is. So -3, we can just factor that out. So instead of putting the 3 here, put it here. -3. Oh, is it? No, it's just going to be cotangent. Cotangent of x plus c. Let's double check, and we are right. A is just 1, so we don't have to do it. So you see u here is just x, a is just 1. This one. So remember, sine is the opposite of cos. Secant and cosecant are opposite. Tangent and cotangent are opposite in sine. Okay, this one's missing a dx. So this one is just going to be cos inverse x plus c, right? U is x, a is 1, right? That's it. I hope you guys have a good rest of your day, and if you have any more questions, please leave them in the comments below, and bye-bye.